Oh. Alright, so parallel and perpendicular, two things kind of important. The first one is parallel. There's a symbol to represent things that are parallel. It's pretty easy to remember because it's just that. Two lines that they look very much like they're
going in the same direction.
Yes, they're parallel. Okay. If you ever need to do that on a computer, it's shift this button. Okay. Alright, so what that means, if we were to have a coordinate grid, so if we drew ourselves a little coordinate grid here, let's say we have this line here, and then we were to draw another line actually, I can do that better. There. Okay. So looking at those two lines, what can we say they have in common? And don't say they're parallel. Very good. Going in the same direction, so what does that mean? Okay, that's... Okay. So let me start this out. They both have the same...
Direction.
Starts with an S. They both have the same slope, thank you. So what can we say about any parallel lines? Okay, so they always... Which is pretty helpful to know. So if we were to give you two equations, it's like if we said could we say those two lines are parallel? No, why not?
They're not the same.
Okay, it's just real easy because they have different slopes. That's the end. Okay? So what the simple fact is saying, parallel lines always have the same slope, it saves us all this trouble of we don't actually have to bother graphing this and then graphing that and then looking at them. We can look, oh, slopes are different, they're not parallel. What if we had... Are any of those parallel?
No. Yes.
Which ones? The first and the last one. Why is that? Because they have the same slope. That's it. Not so bad? Not really? All you're looking at, if you want to know the parallel, you look at this number right here. If they're the same, then they're parallel. If they're different, they're not parallel. This number over here doesn't matter. Okay? All right, good deal. So that's the easy one, which leaves the not so easy one, which is perpendicular. Thank you for reading the title. Perpendicular. Which we don't see quite as often. Trigo, you said you can't see. Sit right here. You say you can't see, then you sit in the very back. It's like, what are we doing? We don't see this quite as much when lines are perpendicular. We say they're what? They make... There you go. They meet at a 90-degree angle. also known as a right angle. Okay? This has a symbol that's also pretty obvious. Has anyone ever seen it before? It's kind of like a T, only upside down. Anyone have an idea of why they would use that as the symbol? Because it makes right angles. Any idea why they wouldn't use a T? Well, it wouldn't look close. Well, if you did a lowercase t, it would. It would look like a letter. This is not a letter, so we can use it as a symbol. On the keyboard, it's not there. Sorry. No. You'd have to go to Insert and then Math Symbols. It would still be a T, though. Yeah, I guess. No. All right, so let's say we go back, we draw our new grid. We take our line from before. And then let's say this has a slope of 1/2. Because it kind of looks like that, right? Except it'd be -1/2. Thank you for correcting me. Nobody. Why do we know it's negative? Because it's going down. All right, so now right now it's parallel. We don't want that. Let's make it purple. So what kind of angle did it have to make? So we have to kind of... So that kind of looks parallel, right? But now the question is, what is the new slope? Well, now it's positive. We know that, right? And instead of sort of slowly going downhill, now it's steeper. So just like Mackenzie said, this new slope would be +2 or 2/1, just so we can see that a little bit better. So what do you think we could say happens to our slope when they're perpendicular? We flip it, and what else? We change the symbol. So negative would become positive, and positive would become negative. So we say the slope will always have, and we'll give the fancy word, the reverse reciprocal. That's probably not how you spell it, but whatever. Okay? Because you think if you kept just the slope the same, like if it was just 1/2, because obviously it can't be going in the same direction. To make a right angle, it's got to be going a different direction, right? But if we kept it at, if we kept it at 1/2, does that look like 90-degree angles? No. And we could really get into why that works, but it's nothing you'd ever be like asked to know. It's just one of those things, like that's how it is. But I'll be here after school. We can go over it. It'll be fun for somebody. All right, if you don't want to remember reverse reciprocal, just remember, flip the slope and the sign. And that's it. Multiplying wasn't hard. It happens. Okay, we got all this? Yes? No? Maybe? Is anyone waiting in line at Best Buy at 6 p.m.? We drove past around 11, and we saw it winding around the building.
I waited. It wasn't actually long.
My friend's dad last year camped out in front of Best Buy.
The line at Target.
Because they had to get all these last year.
The line at Target was like just big and gave me straight up all this time. Wait, if the line was big, go back. I waited for an hour in line at Abercrombie. We're like.
Okay, cool. All right. So, let's say that was our original line. What would be a line that would be perpendicular to that? It wouldn't be negative 3x. Remember, you have to flip the slope and the sign. So it would be a positive would become, and 3, if we flip that over, that would be. And then does this number really matter? No, because there's any number of perpendicular lines, so the intercept part, this could be anything. This could be +1, +2, +3, +100. It could be -1, -2, -1 billion, -3.75, whatever. The only thing we look at when we talk about parallel and perpendicular, the only thing we really care about is the slope. Okay? Piece of cake? So now to make it more difficult? Sure, why not? Alright, so let's say, and it's still in your notebook, so I guess we have to, if we don't do this, everybody gets confused. So how this ties back to point slope. So remember we did point slope? Well, let's say we have this line y, and we want to find a line parallel to that, but it also passes through the point, I don't know, 3, 5.
Is this on the same topic?
Yes. So how could we find the equation for this line? Uh-uh. So you're saying we should graph this one, plot this point, and then plot a parallel line. That's too much work. I want to do this without graphing anything. I just want to use math. Of course you could. Do we have a point? Do we know the slope? If this line is going to be parallel to this line, what is the slope of this line? It is exactly the same. So the slope of this is also 2. So since we have point, since we have a slope, that means we can use point slope form. Of course. And we remember, obviously, because we studied all week, that point slope formula looks like all right, of course. If not, I would write that down again and again and again. Okay? So we just substitute our values in. So this 3 would represent what? That's x what? X1. So it's going to be -3. This 5 would be y1, so this would be minus 5. And then this 2 would be m. We fill in everything else around that, so we have y minus 5 equals 2 times x minus 3. So then we distribute first, so we say 2 times x is 2 times negative 3. I know multiplying's hard. This would be negative 6. Over here, you can't really do anything with y minus 5. So in our last step, we would add 5 to both sides. Why do we add 5 to both sides? Because we want to get y by itself. Very good. So this cancels out, so we get y equals this was point slope, but really we wanted the equation for the line, right? So the reason we use point slope is because when we get down to the very end, we end up with an equation for a line.
It's exactly like that, except
It was just a coincidence based on the numbers we used that it ended up being plus 1 and minus 1. Really the point we're looking at is since they're parallel, what's true about the slope? That they're exactly the same. Unless this point happened to be on that line, then no, they wouldn't be the same. In which case I would have been in trouble for making up my own numbers. Well, what we say, look at the slopes. What's true about the slope? If they're equal, that means they are parallel. All right? Not so bad? That was hard. You want to try another one? Okay. All right, so let's say that's our original equation, and we want a parallel line to that. That passes through. Sure. So what would be the equation of the line that's parallel to this and passes through point 0, 0? So do it just like we did the last one. Good thing you wrote down this last example. And if you didn't, why it's still up on the board for you to look at. Okay, so I see some people with the answer, not including Olivia. So, if we take a look at this, Elijah, do we know the slope of this line right here? What is it? So m is going to be 1/3. Now if we have the point and the slope, what can we use? Point slope form, which will always be y. What? Well, we'll look at that when we get to it. So x and y are both 0. M we said was 1/3. So this is pretty straightforward. We have y minus 0 equals 1/3. So y minus 0 is just y. 1/3 times x is 1/3 x. 1/3 times 0 is 0. So then what is the equation of our parallel line? Wait, what?
She said y equals 1/3 x minus or plus 0.
Well, you could put that, but really it's just
Y equals 1/3 x.
1/3 x.
Couldn't you put like
All right. How do we know they're parallel? Okay. How could we have known this answer without even working it out?
Zero. It's right there already. Just take off the +4.
Because remember we said, what is true about a line that passed through the origin? What did we call that? We said it was proportional. Okay. And then we said, for a line to be proportional, what had to go on the end? Nothing, right? So for a line to go through 0, 0, it's just going to have the slope times x. So something to keep in mind.
Is not everyone here today? Because this week's test.
Oh my goodness. All right, so let's say, yes. So what if we want a, oops. Sorry. That. I don't know how to spell, you know that. Alright, so we want a perpendicular line that passes through. Yeah, we already did that. I'm over that. Let's say 3, 4. Okay? This is the exact same thing as parallel, except for one small difference. Don't tell them. Okay, I'm just telling Javier, don't anyone else listen. So for it to be perpendicular, what's true about the slope?
It's got to be flipped when the signs change.
So we flip the sign, so negative would become
Positive.
we flip 1/2, so that would become 2 or 2 over 1. So for it to be perpendicular, the line would have to have a slope of positive 2. And from there, it's exactly the same. It's not hard. Brian, you all done?
No.
Then put the ruler down. Again, since we have 1 point and 1 slope, we can use point-slope form. We substitute in our values. X1 we know is 3. Y1 we know is 4. And the slope we know is 2. I don't really see how this is hard since this is all whole numbers, none of which are big. So we have to do 2 times x, which is 2 times -3. Oh my goodness. -6. Okay, to get y by itself, we need to add 4. We do it to one side, we do it to the other side, and we end up with that's not hard.
It's actually pretty easy. I got it right.
What's going to be hard is 3 months from now when we try to review this, and I say if you have 1 point and 1 slope, what do you use? And you all just sit there and look at me like, I think there was something like that. And I'll be like, yeah, it has something to do with point and slope in some kind of form, and you'll still be sitting there like, proportions. Okay. They try to keep the names on these pretty straightforward for you, so if you have point and slope, remember point, slope. Okay? Alright. So this just looks confusing because there's semicolons. For number 2, it's saying which, if you have 4 different equations there, which of them are parallel to each other? Well, we say, for it to be parallel, what has to be true? Okay, so which of these have the same slope? Second and third. Is that it? If you don't see x, what is the coefficient of x? 0. So we could rewrite y equals 6 as y equals
0.
And what kind of line would that look like? Well, most lines are straight. We'd say this line exists at every point where y equals 6, which is 1, 2, 3, 4, 5, 6. Anywhere that y equals 6. So it is a horizontal line. Okay. What about this line y equals -8? What would that look like? 0x minus 8, so that would also be, that would be, so are they parallel? Yes. It's parallel to the other one in red. All right. This second one is a little bit more involved. What do we notice is different about these ones?
They have parentheses in them.
So if there's still parentheses, or if y is not by itself, what do we have to do first? We have to get it back into slope-intercept form. So this one's good, this one is not. So we'd say 3/4 times x is 3/4 times -5.
-20.
Here's the important thing. Does it matter? No. What's the only thing we care about? All we care about is the slope. This number over here is totally irrelevant.
If we're just looking for the slope, why can't we do that?
You could, but some people want it. So this technically would be -15 over 4. And then if we added 3 to both sides, again, you wouldn't have to do this because it's only good for showing off that you know how to do math. This would be -3/4.
So you can just do it like that and know that the slope's 3/4?
Yes. Okay? All right, hush. What about this one over here? What's the slope on this last one? So this would be m is. Okay? So which of these pairs have the same slope? Second and the last one?
And the other two.
And so when we circle two of them green, that means the two ones in green are parallel. The two that are circled in red,
The number 2. It confuses you. Like, how do you know that they're like those are 2 different numbers?
but they have the same slope.
0x. She wonders how you got from -8 to get to 0x, and how you got from 6 to
If you don't see x, what does it have to be multiplied by?
0.
So if you don't see x on either of them, that means they're both being multiplied by.
0x.
And the number that x is being multiplied is also known as the. So if they're both being multiplied by 0, it means they both have a slope of 0. And if two lines have the same slope, they are parallel. That's it. Okay? All right, let's take a minute. So you're looking for which of these are perpendicular. Let's take a minute. Okay, so looking at number 5, which of them are perpendicular? All right. The first and second ones are because if you flip 2/3, you get 3/2. And if this is positive, it would flip to negative. So yes, those are. And then we're going to look at the last two. How is that possible?
Because she said so.
Did everyone get one of these? Of course you did.
I gave so you did.
I handed back 28 of these. Did everyone get this paper?
Everyone keeps on here.
Of course
They
not.
didn't get them. I told you. It's not my fault they handed it to me. What was I supposed to do? Keep one.
All right. So, looking at these last two, y equals -1, x equals 3. Well,
That's Y. That's that one and that one. That one and that one.
this one is not so much about, well, all right, this one I would graph it because we're still not very familiar with what this means. If y equals -1, that is what type of line? It's a line where every point on that line, y is -1. So y is -1 here, it's -1 there, 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 there. Which means y equals -1 makes what kind of line? Horizontal line.
That's Y.
Because you look at any of those coordinates, y equals 1. Our second one does not say y equals 3, it says x equals 3, which is a line where what is true about every single point? Or x is 3. So x is 3 right here, x is 3 right there, right here, right there, down in the trash can, which means it's what kind of line?
Vertical.
It's a vertical line, thank you.
But you can have vertical. Actually, that is slightly slanted.
Whatever.
What's the slant? You still.
Okay. What makes this one different is that what's true about the slope here? What happened when Phil tried to walk up a vertical line? He can't. So what's the slope here? It's undefined. So this one, looking at the slopes, doesn't really work simply because this doesn't have a slope. But can we say if they're perpendicular or not? Will one horizontal line and one vertical line make right angles? Yes. Which means, is this third and fourth one perpendicular? Yes. And I know you're looking at me like, but it doesn't match our notes. Our notes said they have to have reverse reciprocal slopes. Well, here's your one example where that doesn't hold up. Sorry. All right, what about number 6? The second and the third one. -7 is the reverse reciprocal of +1/7. And then 7/3, if you were to flip that over and make it negative, you would have -3/7. That's it. All right, that paper that appeared on your desk magically is your homework. Wait, did I just give you guys the answers? Oh, you did that. Oh, okay. I would have felt bad. All right, so start on that. Make an attempt.